Hey guys, this is Mr. Champlin. Today we're going to be talking about conservation of mechanical energy. So the concept behind it, and then we're going to see a sample problem. So first of all, what is mechanical energy? If you don't know, mechanical energy is simply the potential energy plus the kinetic energy. Now remember that potential energy can be GPE, or gravitational potential energy, or it can be elastic potential energy. So there's different kinds of potential energy. So we can write it out sort of in a mathematical way and say that the mechanical energy is equal to the kinetic energy plus the potential energy. All right, so now let's look at it more of a conceptual point of view. So mechanical energy is going to be conserved. That is to say that the mechanical energy before something happens is going to be the same after it happens. So all throughout the process, the mechanical energy is going to be the same. Now that doesn't mean that things don't change. It just means the total amount of mechanical energy is not going to change. Now remember that the total amount of mechanical energy is the kinetic energy plus the potential energy. So one thing I should mention is that when we're doing these problems, we're going to discount friction. So it's like friction doesn't even exist. Obviously it does in the real world, but that makes things a lot more complicated, so we're trying to keep it simple. So as far as this goes, there is no friction. So as you can see here in this figure, we have this little cart, and right now it's moving, so it's got kinetic energy. But it's at the bottom of this hill. It's basically on level ground, so it doesn't have any GPE because it doesn't have any height. Of course, as it goes up the hill, what's going to happen? Well, it's probably going to slow down. So it means that the kinetic energy is going to go down, but because the height is increasing, the gravitational potential energy is going to go up. So they're kind of showing you over here. If you're halfway up or halfway down the hill, doesn't really matter, the KE and the PE should be equal. When you're at the bottom, you're going to have lots of kinetic energy, but no gravitational potential energy. Likewise, when you get to the top, you're going to have lots of potential energy, but no movement or no kinetic energy. So if we look at it from a mathematical perspective, remember that the mechanical energy is the total kinetic energy plus the potential energy. So if we look at the law of conservation of mechanical energy, we can write that as the mechanical energy that we start with, or initially, should be equal to the mechanical energy that we have later on, or our final mechanical energy. Likewise, we can expand that out. We can say the initial kinetic energy plus the initial potential energy is equal to the final kinetic energy plus the final potential energy. And if we expand that even further, of course, you know that the formula for kinetic energy is 1/2 mv squared. So here we have 1/2 mv squared initial. Here we have 1/2 mv squared final. So that's what this is right here. And of course, the GPE is simply mgh. So here is our initial GPE, and then here is our final. So this formula looks pretty intimidating, lots of things going on here, but you're going to see in the simple problem that things get much, much simpler very, very quickly. So here's our simple problem. So make sure you watch the video so you know how to do it. And one thing I also want to mention is that remember that in the simple problem we're using gravitational potential energy, or GPE. However, we could use elastic potential energy and it would work just as fine. We just have to substitute the formula, which is 1/2 kx squared instead of mgh. Now in this particular formula, they're using 1s and 2s instead of i's and f's, but it's really just the same thing, right? It's just your initial kinetic energy plus your initial elastic potential energy should be equal to your final kinetic energy plus your final elastic potential energy. All right, so I hope that was helpful. Again, if you have any questions, make sure that you contact your teacher, and we'll sort things out.